Scientists have just come up with new solar cells that could pave the way to running solar panels at night and indoors, while getting energy from them to run your devices. A team from National Yangming Chiaotung University in Taiwan has developed a new generation of Perovskite solar cells that can efficiently harvest energy from indoor lighting and even under cloudy skies. This breakthrough could expand how and where we use solar energy. To develop these advanced solar cells, the scientists focused on engineering the material at the molecular level. They altered the bandgap of the perovskite composition by tuning the material to respond more efficiently to low-light conditions. In technical terms, the bandgap is the minimum amount of energy required for electrons to move from a lower energy state to a higher one, which is critical for generating electricity. By carefully adjusting the ratios of the molecular components in the solution used to create the perovskite layers, the team was able to craft a bandgap that is ideal for absorbing the wavelengths of light commonly found indoors. This finely tuned bandgap allows the solar cells to perform exceptionally well under dim lighting, which is not achievable with traditional silicon solar panels, which have a fixed and less adaptable bandgap structure. Under typical office lighting, which sits around 2,000 lumen per square meter, the new perovskite cells hit a power conversion efficiency of 38.7%. That's an extremely high number, considering that some of the best traditional silicon solar panels only reach around 26% under full sunlight. With this tech, even wearable devices can generate their own power just from ambient light. And while we're not yet at the point of generating solar power in complete darkness, this breakthrough does pave the way to running solar cells during nighttime by using artificial indoor lighting.